Now let's try to solve a similar kind of question. Here the question is starts and ends with different symbol, and this is the answer, right? What if the question is starts and ends with same symbol? So let us try one more question where it starts and ends with same symbol. Okay, now this is for different symbol, starts and ends with different symbol, and now I am going to do for starts and ends with same symbol. First let's write down the language. So language is going to be epsilon is going to be present in the language because epsilon is going to start and end with same symbol, and small a is going to be present in the language because a is going to start with a and end with a. B is going to be in the language, AA is going to be in the language, and BB is going to be in the language. What about this one? Starts and ends with different language, different symbols. If you have seen this, it is going to be A, B or BA, and then A and let us say B, and then A and let us say B, and then B, let us say A, B, and let us say A, so on. So if you look at these two languages, both are exactly complement. If a string is going to be in this language L1, the string is not going to be in this language L2. Let us call this one as L1 and this one as L2, right? And they are exactly complement of each other, right? And L1 union L2 is going to be everything. So let us try to design this. Whenever we have to accept epsilon, I am going to have initial state as final state. Next thing is I have to accept A and I have to accept B, and I should even remember that string starting with A should end with A and string starting with B should end with B. I have to remember that at least. Therefore, for string starting with A, I'll go in this direction, and for string starting with B, I'll go in this direction. If the string is going to start with A, I'm going to go in this direction, and if the string is going to start with B, I'm going to go in this direction. Okay, now the question is if a string is going to start with A, it has to end with A. So see this, if a string is going to start with A, it has to end with A, and therefore A is there in the language, so I have to accept it, and B is there in the language, so I have to accept it. Okay, now let's look at this path. If it starts with A, it can contain any number of A's, which means all the A's definitely are going to start and end with A. If I get a B, I should reject it. Right? And here if I get a A, I should reject it. Which means if a string is going to start with A, if it ends with B, I am going to reject it. If a string is going to start with A, any number of A's is nothing but ending with A, I am going to accept it, right? So let's see about this DFA. Is this DFA? It is not DFA because all these states are not complete. This state is complete, this state is complete, and this state is incomplete, and this state is incomplete. Let's talk about it. See this, if a string is going to start with B, if I see any number of B's, it is still ending with B, therefore I am going to accept it. So this state is complete. And what about this state? If a string is going to start with B, if I reach this, which means it is going to end with A, and if I see a B, it is again going to end with B. If I see any number of A's, I'll be here. Just see this. Now, if I had taken this path, which means string is going to start with B, then I am going to accept all the strings which are going to end with B. B is going to end with B, or B followed by any B's are going to end with B, or B followed by A and then again B ending with B, right? Or if you take A, again B. If you take A any number of A's, again B. So only way I can reach D is when the string is going to end with B. Similarly, in state C, if I see a, it means the string is going to end with A and I should accept it. And if I see any number of B's, it means that string is going to end with B, I am not going to accept it. Only way I can reach B is if I see a string ending with A. If I see a it is going to end with A and I accept it, and any number of A's, it is going to end with A and I am going to accept it. Or I can even come this way. So only way I can reach B is when the string is going to end with A, and only way I can reach D is when the string is going to end with B. Therefore it is starting with B, ending with B, starting with A, ending with A. Now you just compare this finite automata with this one. The finite automata, the DFA, which accepts set of all strings over A comma B, where each string is starting with same symbol, with the DFA, which accepts set of all strings over A comma B, where each string is going to start and end with different symbols. If you see this, both are having exactly the same transitions, same number of states. Only change is here the initial state, here the non-accepting states, or accepting states here, and here the accepting states or non-accepting states. And these such kind of DFAs are called complement of each other. If L1 represents a language accepted by this automata DFA, L2 represents the complement of it. In fact, the languages are complemented, therefore we get the DFAs as complemented. So let me do something here. Complementation. So first of all, a language is said to be complement of other language if I can get L2 by removing, if this is the condition, then I can say L1 and L2 both are complements of each other. For example, set of all strings of even length is a complement of set of all strings of odd length. In this case, L1, which is starting and ending with different symbols, is a complement of starting and ending with same symbols. And if you look at these diagrams, this process is also called as complementation. You need not construct this diagram. You can construct this diagram, this DFA, and then just reverse the states, which means whatever are the non-accepting states here, you make them accepting here, whatever are the accepting states here, you make them as non-accepting here, then we get a complemented. So let's talk about complementation now.